A streamlined car flashes by at over 300 kilometers per hour. But there's no sound of an engine. This is an electric car, propelled by motors and batteries. With 8 wheels and more than 600 horsepower, it's a genuine supercar. It was developed by Professor Hiroshi Shimizu of Japan's Keio University. For over 20 years, he's been developing electric cars in a quest to promote adoption of environmentally friendly vehicles.
電気自動車が環境に優しいだけでは世界に普及しないと考えています。これまでの車に比べて性能的にパワー的に高いものを持って初めてそれが普及するというふうに考えています。
Previous electric cars have been seen as lacking in power and speed. But the car Shimizu is developing is intended to reach 400 kilometers per hour. It will be the fastest electric car ever made. A high-performance car with no exhaust emissions. Follow along as 1 year in its development unfolds. The electric supercar is named Eliica. Full-scale development got underway in September 2003. On this day, Shimizu was working out details of the Eliica's body using a full-scale clay mock-up. Typically, only experienced engineers working for a car manufacturer can develop a car from scratch. But Shimizu has never been affiliated with any car manufacturer. While teaching university classes on environmental issues, he works with students in the lab to develop electric cars. Working to turn his vision into reality, he has funded a series of electric cars by applying for grants from government projects. He has received no support from car makers. This will be the 8th electric car his lab has made. Shimizu first tried his hand at building an electric car in 1983. He took the engine out of a used car that he got from a friend, then fitted the car with batteries and electric motors. At the time, he was working at the National Institute for Environmental Studies and was an amateur at building cars. So why did he begin electric car research? It all started with an instrument he developed to measure air pollution using laser beams. This pioneering development enabled instantaneous measurement of air pollution across the whole Tokyo metropolitan area. But Shimizu felt that simply taking measurements did nothing to actually solve environmental problems. Sensing the limits of his current research, he began to see the potential of electric cars. After making 4 prototypes, Shimizu conducted full-scale development of an electric car in 1996. The result was a compact 2-seater called Lucio. Shimizu was proud of the little car, which could do 150 kilometers per hour, be recharged at home, and squeeze through narrow streets. He promoted the car in Japan and around the world. People who test drove it gave it high marks. But no serious buyers materialized, and to Shimizu's disappointment, there were no inquiries from car makers.
Lucioはかなりうまくいった車だという自信がありました。しかしそれでもまだ社会で受け入れられるには足りないということを強く感じまして、電気自動車は環境に優しいということだけでは普及はしないということでした。で、それをもし普及するとしたらガソリン自動車にない何かというものが必要だということですね。でそれはまさしくパワーだということです。でパワーということは速いと、あるいは加速がいいということなんですね。それがガソリン自動車に加えられない限り電気自動車というのは普及しないというふうに考えたということでした。
To develop an electric car with better performance than a gasoline car, Shimizu partnered with industry for the first time. He recruited companies that included makers of motors, batteries, and other components, a total of 35 partners. This brought Shimizu 500 million yen in funding and access to specialized expertise. Shimizu's electric car development is being undertaken by manufacturers that are not involved in conventional car making. The motors that will drive the car are crucial. This factory builds custom-designed electric motors. To take the car to a speed of 400 kilometers per hour, Japan's high-performance motor technologies will be essential. Eliica runs on 8 wheels. Each wheel has a motor inside it. The motors are each 18 centimeters wide, and each of them must produce 80 horsepower to take the Eliica to 400 kilometers per hour. The key to achieving this power is the coils inside the motors. A coil's strength is determined by how densely it's wound with electric wire. Shimizu has assigned this task to Yoshio Kato, an engineer with 40 years of experience. Kato will need to push his coil winding skills to their very limits. No one has ever managed to wind a coil so densely that it can generate such high power within such small dimensions. Conventional winding methods make the wire protrude, so the coils won't fit in a motor that's only 18 centimeters across.
真っ赤ですね。これはね、もうなんとかでも少しでも何回か試してもこれを中側へ飛び出せないようなことまでやらないと製品になりません。
Through trial and error, Kato comes up with a winding method in which the nozzle that feeds out the wire and the holder for the coil both move. This allows wire to be wound more densely than ever before.
これなら十分問題なくいけると思います。
こういう努力に支えられてなんとかやってきたということですけども、
それを先生がみんなまとめておられるんじゃなくて、先生がいないとみんなバラバラで何の役にも立たない。先生が要になってるからみんな僕らが力を発揮できるものです。
Japanese technology has realized these tightly wound coils. But the coils alone are not enough to produce 80 horsepower. There's another vital ingredient, a revolutionary permanent magnet technology for the motor shaft. A rare earth permanent magnet of unprecedented strength is used. Invented by a Japanese manufacturer, it's said to be the world's strongest magnet. It can attract 5,000 of these steel balls. The magnets in just one of the Eliica's motors can hold up a steel mass of more than 1 ton. This kind of magnet enables a motor more powerful than any other to be built. Once the 80 horsepower motor is completed, work on the building of the car surges ahead. A conventional car has design limitations because of the engine compartment, but the Eliica has a flat chassis bed that allows a body frame of any shape. Should electric cars be widely adopted, this kind of construction will revolutionize the auto industry. Many parts, like engines, transmissions, and clutches, will become unnecessary, as will using gasoline. Instead of an engine, an electric car has motors at its heart. In Shimizu's design, each of the 8 wheels has its own in-wheel motor. Because the motors drive the wheels directly, hardly any energy is wasted in transmission. This is cutting-edge eco-car technology. Shimizu first experimented with in-wheel motor technology more than 20 years ago when he made an electric bike.
これがそのバイクです。で、特徴としては車輪の中にモーターを埋め込むという形で、ここの車輪の中にモーターを入れるということになるんです。はい。
One of the biggest shortcomings of electric vehicles is short range. To enable a longer driving range, energy losses must be minimized. After wrestling with this problem, Shimizu hit on the idea of placing the motor inside the wheel itself.
この車輪の中にモーターを入れるというアイデアは自分のアイデアかなと思って、非常に嬉しかったですね。そのうちにいろいろ文献を調べているうちにですね、どうも昔ポルシェがですね電気自動車をやってた時代がありまして、その当時そのポルシェもこういう同じようなことを考えてたということが本に載ってましてね、少しがっかりでした。自分のオリジナルアイデアではなかったという意味で多少がっかり、それから、だけども有名なポルシェが考えていたということで、半分嬉しかったということですね。
The idea of the in-wheel motor was first proposed by Ferdinand Porsche, an engineering genius and automaking pioneer. This electric car, built by Porsche in 1900, was powered by in-wheel motors. The round housings inside the wheels are the motors. When he built this car, Porsche was focused not on cars with internal combustion engines, but on electric cars. A great exposition was held in Paris in 1900. It was here that Porsche presented his electric car to the world. It had a top speed of 50 kilometers per hour and could run 50 kilometers on one charge. For the time, this was revolutionary performance. The car won the prestigious Grand Prize in Paris. Electric cars actually have a longer history than engine-powered cars. They were common on city streets early in the 20th century. Electric cars didn't vibrate much, and they were quiet. At one time, they outnumbered engine-powered cars in Europe and America. But thanks to a production method invented by American car maker Henry Ford, engine-powered cars rapidly grew in popularity. Ford's assembly line system made mass production possible, dramatically reducing costs. The performance of engines also improved. And in the early years of the 20th century, oil was discovered in many parts of the world. It provided cheap fuel that could be supplied in huge quantities. While engine-powered cars quickly became more numerous, no advances were made in batteries and motors, and interest in electric cars waned. It's been 100 years since cars with gasoline engines took the world by storm. Now society is turning a critical eye on engine-powered vehicles. As air pollution and global warming worsen, there's a growing shift from engine-powered vehicles to eco-cars. Automakers are now in a life-or-death struggle to develop next-generation cars that dispense with internal combustion engines. This is a hybrid car, which combines an engine with an electric motor to achieve major reductions in emissions. Hybrids are much gentler on the environment than conventional cars, so they're starting to become popular. The symbol of future eco cars is the fuel cell car, which extracts energy from a reaction between oxygen and hydrogen. Many hurdles related to production costs and handling of hydrogen must be overcome. It will be a while before fuel cell cars become common. Shimizu is working to achieve a resurgence of rechargeable electric cars. Advances in motors and batteries are close to making electric cars practical. If electric cars can surpass engine-powered cars in power and speed, they'll reclaim the market, according to Shimizu. It's a dream of a return to the preeminence that electric cars once enjoyed. Construction of the Eliica electric car now approaches the most crucial challenge: a high-speed running test for the motors. For the Eliica to reach 400 kilometers per hour, each motor will have to run at 12,000 revolutions per minute. It's possible to adjust the speed of an electric car by simply regulating the current flowing into the motors. The crucial regulating component is called an inverter. No one has ever before made an inverter capable of controlling a compact motor producing 80 horsepower and running it over 10,000 RPM. The challenge is tackled by a 50-person company that makes inverters for industrial robots and machine tools. The company has never been involved with the car industry. Japanese inverter technology is considered the best in the world. It has become the focus of Shimizu's attention. The motor spins up smoothly past 8,000 RPM. But just before 10,000, something goes wrong. The motor stops. How exactly does the inverter perform the difficult task of controlling the motor as it runs at high speeds? The inverter monitors the positions of the magnets. It uses this information to calculate how much current the coils require and instantly issues the necessary commands. The faster the motor runs, the more crucial is the time lag between taking a measurement and issuing a command. Time lags were calculated in advance and factored into the inverter's programming. But when the speed approached 10,000 RPM, a voltage built up inside the motor, and a phenomenon that could not be understood using known theory made the motor stop.
予想がつかないというよりも、やはり今言ったように計算通りにいっていないというところですね。そこがなぜかと、今までそんなことはなかったので、あまりにも限られたデータが出ているというところです
ね。The engineers had plunged into an unknown realm where theory no longer held up. They struggled onward. Japan's bullet trains are famous for their high speed. That speed also comes from high-performance motors and inverters. The bullet train's motors have a maximum speed of 6,000 RPM. The 12,000 RPM that Shimizu and his colleagues targeted was new, uncharted territory. Developing the Eliica meant figuring out how to control motors running twice as fast as those on the bullet train. Known theory could not explain why the motor had stopped during the test. So the team discarded the theory and powered up the motor. They decided to tweak the parameters by hand to figure out how to run the motor most smoothly, and then modify the inverter program accordingly. It's time to run the motor using the modified program. Once again, the team aims for the unknown territory, around 12,000 RPM. The motor speed rises smoothly past 10,000 RPM, then climbs past the 12,000 RPM mark. At last, they've succeeded in controlling the motor at unprecedentedly high speeds.
いや、やっとほっとしました。最高まで行けたんで、とりあえずまあ大丈夫か、今のところは大丈夫かなという感じですね。
一番大事なところが OK ということですんで、これはこれで一安心です。ですから30分前とは態度がだいぶ変わりました。
In February 2004, serious test drives of the Eliica began at a track in Tochigi Prefecture. The car was driven by Formula One veteran Ukyo Katayama. 400 kilometers per hour is even higher than the speeds reached in Formula One. How fast can the Eliica really go? Will the motors and inverters function properly? The only way to find out is to drive the car at high speed. Most electric vehicles produced until now have been special purpose vehicles like golf carts. They're not intended to travel fast or over long distances. The Eliica is ready to shatter the perception that electric cars are quiet and eco-friendly, but no fun to drive. An electric car doesn't produce the distinctive rumble of an engine. The Eliica sounds more like a jet aircraft as it speeds up. But the Eliica is economical as well as powerful. If the electricity it uses is calculated in terms of gasoline, the Eliica is more than twice as fuel efficient as an engine-powered car with the same weight and running performance. Packed with the best of Japanese technology, the Eliica runs faster and faster. As Katayama floors the accelerator pedal, the car rockets past the 300 km/h mark. In this test, the car reaches a top speed of 320 km/h. For safety reasons, it can't go any faster on this particular track. Later, on a track in Italy, the Eliica will reach 370 km/h. No sedan-type electric car has ever clocked speeds like these. As a further demonstration of the Eliica's high performance, Shimizu and his colleagues arrange an acceleration test. Does it really have more power than a car with an internal combustion engine? The Eliica's opponent is a Porsche. After working on electric cars 100 years ago, Ferdinand Porsche began working on cars with internal combustion engines. The company he founded became one of the world's top makers of high-performance sports cars. Can the electric Eliica defeat a Porsche, the ultimate in engine-powered cars? Acceleration performance will be measured by the time taken to reach 160 kilometers per hour. They're off. The Eliica is the first to reach 160 kilometers per hour. Let's see it again. First, the Porsche sprints into the lead. After 3.8 seconds, the Eliica matches the speed of the Porsche. Once the speed hits 100 kilometers per hour, the Eliica pulls away from the Porsche. The Eliica hits 160 kilometers per hour in just 7.04 seconds. At this moment, the Porsche is doing 138 kilometers per hour. The Porsche doesn't reach 160 kilometers per hour until the 9.2 second mark. This is proof that the Eliica can accelerate just as well as the fastest engine-powered cars.
まあ電気自動車っていうのは加速が悪いというのが今まで一番のまあ批判の対象だったわけですけども。
ね、ポルシェは2秒以上ぶっちぎる加速って言ったら多分ちょっとみんな乗っけてあげたいなってぐらいでびっくりしますよ。で0-100もそうなんですけど、とにかくありえないのは120キロからアクセル30に踏んだ時の加速が0-100と同じ加速を繰り返すんですよ。でエンジンでは絶対起こりえないことなんで、アクセルポンと踏んだだけで同じ加速をキューンキューンっていうのはまるで映画のそのバックトゥザフューチャーなんかがこうシューッとしててシュープシューってこれからどっかワープしていくように。
This electric car can accelerate right up to top speed faster than an engine-powered car.
100年前にパワーが足りないということで電気自動車がガソリン自動車に負けたという時代がありました。そして今100年ぶりにガソリン自動車をしのぐパワーの車が生まれたということで、このことがその電気自動車のが次の時代の新しい車になるんだということを強く実感したという意味で今日は非常にいい日だったというふうに思います。
The Eliica has proven its outstanding performance. At Keio University, they now begin turning it into a practical car with the potential for widespread adoption. The students in the lab take charge of this phase of the project, installing navigation and air conditioning systems in the Eliica. The Eliica can go 300 kilometers on one charge. Lithium-ion batteries have enabled this electric car to overcome the problem of limited range. Lithium-ion batteries, which offer good storage capacity and power, were refined in Japan. The Eliica uses large lithium-ion batteries specially developed by a battery manufacturer for use in electric cars. The car has 320 of these batteries. Large lithium-ion batteries are not yet mass-produced, so the number needed to power one car currently cost almost 20 million yen. This high cost is one reason automakers have shown only limited interest in electric cars. To make electric cars readily accessible, many industries will have to play a role. So the Eliica project includes a professor with proven clout in the business world. Hiroichi Yoshida was formerly the vice president of a major bank. Yoshida is responsible for crafting a strategy for developing an electric car industry. He also uses his connections to raise funds for the development project. So far, most of the financial backers of the project have been companies like electric utilities and house builders that are interested in getting into environmental businesses. But discussions with car makers have been surprisingly fruitless. On this day, Yoshida and Shimizu are heading to negotiate with the company. The company they're visiting is a startup that leases electric generators and retails electricity. Its last year's sales were more than 50 billion yen. The purpose of the visit is to ask the company to financially support the second phase of the project, which is aimed at mass production. This company has been the project's biggest backer. It's vital to secure the cooperation of its president.
自動車っていうのはものすごくお金がかかるということも含めてこの第2プロジェクトをどうしても乗り越えないと私どもは実用化されないと。で近づいてみえたけどこれを超えるのが大変だということでその、深尾社長のお力を借りたいというのが一つでございました。
実は第2ステップになりますと、いよいよ自動車の方の、車躯体の問題とか耐久性の問題とかそちらの方になってまいります。で我々の一番興味を抱いたのはこのリチウムイオン電池でございまして、やはり今後2度目の資金協力といいますか、その辺についてはちょっと我々としては研究開発投資に資金を投下しなきゃならないから、なんとかこれはご遠慮申し上げたい、お断りをできたら、お断りをしたいと、実はこれは本音でございますな、先生。開発させていただいて、
The company president they had been counting on has turned them down. If this is how it ends, they will never be able to carry out plans to develop the car for mass production. Although the president is interested in lithium-ion research, he's deeply concerned about the profitability of electric cars. The discussion continues for 2 hours. In the end, they persuade him to maintain funding by explaining that they will establish a project for low-cost mass production of lithium-ion batteries. The Beijing International Automotive Exhibition, June 2004. China is rapidly becoming an automotive society. It could pass Japan to become the world's second largest car market in terms of unit sales as soon as 2005. Yoshida and Shimizu, hearing that development of electric cars is taking off in China, go to investigate firsthand. An electric car on display at the motor show grabs the two professors' attention. It's designed as an electric taxi. It was developed by a battery maker with no previous connection to cars. With a maximum speed of 125 kilometers per hour, carrying 4 passengers, it can't rival the performance of Shimizu's car. But the company plans to ship 50 electric taxis to the city of Shenzhen in southern China within the year.
1日に何キロぐらい走るんですか、タクシーは？
我们是靠充电，这个电动汽车呢是每充一次电可以跑300到350公里。
そうすると大体1日のその走行キロが1回の充電で済む。也就是说，一天的跑的这个量大概充一次电就够。顺路过来的是。
这个何ですか？
电池的种类是
锂离子电池。
リチウム電池。
Yoshida and Shimizu are surprised to learn that a Chinese company has developed powerful lithium-ion batteries for cars. They decide to pay a visit to the battery maker that's building electric taxis. The factory occupies a vast 600,000 square meter site. The company employs more than 30,000 workers who make enough lithium-ion batteries for a number 2 global market share. This is the newly developed lithium-ion battery for cars. Enough of them to power 1 car cost about 2 million yen, much less than in Japan. The most competitively priced lithium-ion batteries in the world are powering this company's attempt to create a cheap electric car that can win in the marketplace. In one corner of the factory, electric cars are being produced. The battery maker has accomplished all this in just 2 years. This speedy development has been spurred by China's severe air pollution problems. Electric cars help limit emissions. There's a big demand for them in China. This battery maker plans to supply 400 electric taxis to major Chinese cities. On the vast site, factories that will make lithium-ion batteries and electric cars are under construction. Once they are completed, mass production will begin in earnest and prices will drop. A 100 years after Ford's manufacturing revolution ensured the triumph of engine-powered cars, the Chinese battery maker is aiming to become the Ford of electric cars.
China 的这个汽车工业啊，和全球的或者比较领先的汽车工业，至少有10到20年的这个差距了，这个大家都这是应该要承认的。那么在电池上讲的话呢，可能也有差距，但差距不是说他们比我们好，是我们比他好。因此，我觉得电动汽车的话呢，对中国人，对我们中国来说，应该是一个机遇，是我们在汽车上面能够接近国际水平，或者说能够甚至超过国际水平的一个非常好、非常难得的这么一块领域。
A battery maker rushing toward production of electric cars. Linking up with this company could bring Yoshida and Shimizu a step closer to mass production. So the 2 professors have a meeting with the battery maker. It's attended by technical managers working on electric car development.
これは日本のテストコースで走った時のもので、最高速度が320キロ。
The Chinese engineers are mesmerized by the high performance of Shimizu's electric car, the Eliica.
这太快了。
他这个。
首先，我向您取得的成就啊，表示崇高的敬意。我就是读过，我和这几位工程师就是读过他和他的研究小组啊，以前发表在就是世界电动汽车大会的会议集上面的所有的论文。
The engineers have already studied Shimizu's work. By devouring information from all over the world, they've been able to develop an electric car very quickly. If they can now work with Shimizu, they will be able to create cars that lure buyers not just with cheapness, but with performance too.
那我们也感觉到，我们相比我们自己的车辆，我们确实觉得我们有很多问题还要去完善。我们也真诚的希望有机会能跟两位教授合作。
The Chinese make a proposal for technical cooperation. But the electric car technology developed by Shimizu is a product of Japan's manufacturing industry. Would it be right for Shimizu to link up with the Chinese? The proposal is exciting, but an immediate reply is impossible. In the end, the Japanese decide to hold off on the technical cooperation agreement.
電気自動車を普及をさせるという点では、日本も中国もそれから世界中一緒にやるべきだというふうに思います。でそういう意味では一緒に やろうというふうに言ってもらえたのはとても良かったというふうに思います。でその時にこちらが全部取られてしまうということがないようにするということが大事だと思いますけれども、それについては、我々がもっと先に進むということ以外に方法はないというふうに思っています。
China is a long way down the road to making practical electric cars. Japan has superior technology, but trails far behind in putting it to practical use. In late August 2004, an automaker finally begins to show interest in the Eliica. The car is transported for a test drive. It arrives at a Mitsubishi Motors plant. For electric cars to be mass-produced in Japan, an automaker will have to be involved. Yoshida and Shimizu have been trying to persuade this company. The audience is a group of business and engineering managers. It's their first look at the 8-wheeled electric Eliica. They all examine it closely and try to evaluate it. The test drive begins. The automaker has provided one of its latest 4-wheel drive cars for the acceleration test.
これからやはり環境に優しい技術が重要ですけども、やっぱりと同時にやはり車っていうのは人類にその夢を与えたりね、利便性を与えるようなものですから、そこをどう生かすかがね課題で、それに対して十分今のものとは違ったポテンシャルがあるということを予感させますね。
For more than 20 years, the auto industry has ignored Shimizu's efforts to make electric cars. Today, though, the performance and potential of electric cars have been acknowledged by an industry player. But there are still countless obstacles to overcome: safety, reliability, production costs, and more. The determination of one university research team, backed by the prowess of Japanese manufacturing. It's a combination that has produced the world's first electric supercar. Will it lead to widespread adoption of electric cars? Much work lies ahead before that question can be answered.